In this example, you're asked to find all the missing parts of a triangle where side B is 21 feet, side C measures 25 feet, and angle A is 63 degrees. So the first thing to do would be to draw a picture. And so I'll just draw a pretty generic triangle here. Label the angles A, B, and C. And I'll write in red what we know. So we know that angle A measures 63 degrees. We know that side B, which is going to be the side down here opposite angle B, measures 21 feet. And side C, so that would be over here opposite of angle C, measures 25 feet. So the first thing is to decide whether to use law of sines or law of cosines. Law of sines is preferable when you can use it because the equation's just simpler. I mean, C over sine of C equals A over sine of A, and so on. However, you can only use law of sines when you have a complete set. So when I know side C and angle C, or side B and angle B, and you get the idea. In this example, so we know angle A is the only angle we know, and we don't know side A. Remember that you cannot use A squared plus B squared equals C squared unless you know you're looking at a right triangle. And most likely this is not a right triangle. So we cannot use the Pythagorean theorem. So that leaves us with the law of sines, or cosines, I'm sorry, which I'll jot down here. Oops, okay. And let me put it in the form that we're going to use. So suppose we solve for angle A. Oh, sorry. We know angle A. So, okay, sorry, lost my train of thought. We know angle A, so we can use law of cosines to solve for side A using this form of the law of cosines. A squared equals B squared plus C squared minus 2 times B times C times cosine of the angle between them. Cosine, let's see, I was saying side B times sine C times cosine of the angle between them. There. Okay. And we know all of these quantities. We know side B, side C, and angle A. So now it's just a matter of computing that. So this will be 21 squared plus 25 squared minus 2 times 21 times 25. I'm going to run out of room a little bit. Times cosine of 63. Make sure you put your calculator in degree mode when you type that in. You should get about, let me see, I jotted this down ahead of time, 589.30997. Something like that when you put that into your calculator. Now remember that that's equal to A squared. So side A would be the square root of that, which is about 24.3. So we'll use that for our side A. So we've now calculated that side A over here is about 24.3 feet. Now we need to find the two missing angles. Solving a triangle, by the way, means finding all 6 parts. We were given 3 parts, and so we're trying to find angle B, side A, and angle C. Once we find one of these, either angle B or angle C, then finding the third angle is easy. It's just 180 minus the 2 angles that we know. So the only real substantial task we have left is finding either angle A or either angle B or angle C. Right, so let me get, quick copy of that triangle jotted down here. C was 25 feet, B was 21 feet, and we just found this was about 24.3. Okay. So let's say we go for angle B next. We can now use law of sines because we do have a complete set. We have angle A and side A. And so I use law of sines whenever I can. Like I said, just because that equation's simpler. You can put the sine of A and sine of B either in the numerator or the denominator, whatever's more convenient. If we're solving for the angle, then I would put the angle in the numerator. So I would write it as sine of B over side B equals sine of A over side A. And so plugging in what we know, okay, we don't know angle B, that's what we're looking for. We know that side B is 21 feet. We know that A is 63 degrees. And we know now that side A is 24.3 feet. And so we've done this before in the last section. Multiply both sides by 21 to cancel. And then input that into your calculator. Be careful, like I keep saying, when you press the sign button and say a TI-83, I believe, it automatically opens the parentheses. So make sure that you close it after you put that in. Okay, I worked this out ahead of time too. So this, when you do this computation right here, you get about 0.770776. Now, we have to consider all possible solutions. So if the value of sine is 0.77, so that's, if I'm picturing the unit circle, remember that sine is 1 up here. Sine is the y-coordinate. So you have 1 up here, so 0.77 is somewhere, about here. This is just a rough approximation. I just want to point out that there are two angles between 0 and 180 degrees. None of these angles could possibly be more than 180 degrees if it's inside a triangle. But there are two angles between 0 and 180 degrees where the value of sine is 0.77, whatever. If we take inverse sine, so I'll call this B1 for now. If we take inverse sine, oops, that's sine with the negative one there, inverse sine, of this value right here. So if you just do inverse sine answer in your calculator, if you can do that, that's ideal to avoid rounding off, but if you have to, you can put it in the 0.770. Write as many, type in as many digits as you can stand typing in there to get your answer as accurate as possible. But you get about 50.4 degrees. Okay, so that's for angle B up here, 50.4. Now, if we were considering the possibility of a quadrant 2 solution, we would use reference angles. So we'd say, okay, well, let me make this reference angle over here. It's got to be the mirror image of this angle over here, but over in quadrant 2. So if this is 50 degrees over here, then this is going to be 50 degrees over here. 50.4. So if we measure the quadrant 2 solution around this way, quadrant 2, that angle would be 180 for the whole upper half of that circle, minus that piece that where we wrote the reference angle. And so that gives you 129.6 degrees, which is too big, because we already have 60 degrees over here, or 63 degrees over here. If you add 63 to that, you're going to get something that's more than 180. Remember that the sum of all three angles has to be 180 degrees. If you take angle B here and add 63, you're already above 180 and you haven't even accounted for angle C. So this is not possible. In this case, we considered the possibility of a quadrant 2 solution, but it won't work. So there's only one solution for this triangle. Angle B is 50.4 degrees, and angle C, I'm sorry, I'm going to squeeze it on this page, is 180 minus the 63 for angle A, minus the 50.4 for angle B, and so that gives you 66.6 degrees for angle C.